Hello team. So basically we're going to be doing this one here between the two sets, right? So it's quite confusing. It's very confusing, right? So the best the most important thing is to understand what they're asking you to do. And the best way to do that is I found this explanation in here. That's probably one of the best explanations, right? So what they're asking you to do, right, is basically put it this way, right? You have numbers in here. It can be infinite number of numbers. I think up to 10 it goes, right? And then you need to create array of multiples per number. So 2 multiplied by 0, 2 multiplied by 1, 2 multiplied by 3, 2 multiplied by 4, whatever, right? Up to, I don't remember, it's either 10 or 100, right? I think it's up to 100. What are the constraints? I think it's up to 100. Yeah, it's up to 100. Okay, right? Next is, so you can imagine you have like, I don't know, 10 arrays, and all of them have multiples of each other, right? Well, not each other, but I mean multiples of 1 multiplied by 2, like 0 multiplied by 2 is 1 multiplied by 2, 3 multiplied. How to explain this the best way? Let me just do it in here. Yeah, let me just do it in here. Look, so you're gonna have first array with like whatever. So first thing you need to do is you need to do this, right? So these are gonna be all your multipliers. So this is gonna be up to 100, all right, including 100. And then you're gonna have an array. The array is gonna be called A. That's the first array. And then you're gonna have numbers in it, whatever, 3, 6, whatever, right? 8 or 9, right? Oh, whoopsie, let's just do 5. And then just do, what, makes no difference. I'm just um, 8, okay, like that, all right? So what you're doing here is you need to multiply 3 multiplied by this number here. Then we do 7 multiplied by this number here, right? Then we need to do 8 multiplied by this number here. Now, you cannot hard code it, right? Because this array can be unlimited number of numbers, up to 10, I think, right? Okay, so the next thing, that's the requirement number 1. So we're talking about requirement this one here. That's the first requirement, right? And then you need to pick out numbers that exist in all of those in every single array. All right. So I don't know. Let's find a common number that exists in every array. Let's just do maybe. Let's just find one. I don't know. Okay, so we found 21. 21. Well, which number will be a multiple of 3, 7, 8, right? But you get what I'm saying. You have to find common number, right, in here. So let's do, I don't know, let's do 2 and 4. So this will be 2. And this, let's say, they give you 2 and 4 array with 2 numbers in it, right? I'm just doing it so you can see that what we're looking for. Okay, so common, you see, so there's 4, which is common, which is 8, which is common. We see 12, which is common, right? And so forth, right? So that's going to be your first requirement, right? The second requirement is to do it. You have your whatever 24, 36, right? And you have to do something very similar, only you have to divide evenly, right? So you can imagine this is going to be up to 100 again, right? And then we have array B, which is going to have 24. Well, whichever numbers they're giving you. 23, 24, and 36, okay? So again, we are going to check whether 24 divided by 0 um, gives us, do you know that thing, remainder, I think it's called, 24, remainder 0, should be equal to 0. So when that happens, right, what we're getting is we're getting factors of 24. Right, so we're gonna have a gigantic list of numbers. Well, not very gigantic because 24 is not a lot, but I mean 24 divided by 0 is gonna give us 0. 24 divided by 1 is gonna give us 24. 24 divided by 2 will give us 12. 24 divided by 3 will give us 8. 24 divided by 4 will give us 6, I think, right? And so forth. You see, you do it for every number. Then you're going to have a list of numbers in here and in here. And then again, you have to pick the common one, right? So let's say, let's ignore 36. Let's pretend it doesn't exist, right? So we know that 12, right? 8, 24 divided by 5 is going to be non-applicable. 24 divided by 6 is going to be 4, right? So we can clearly see that 12, 8, and 4 are all in every single one of them, right? And that will be our answer. How many of these numbers are basically common to every single one of those arrays, right? So if you read in here, it will take you a bit of time to figure it out, but that's effectively what they're asking, right? So just think about it this way, right? We create up to 100, up to 100. Then we create, for array A, we create multiples, right? And for array B, we create factors, right? So factors is if you take 24, you divide it into whatever number, it gives you 0 as a remainder. I'm talking about the number as a remainder, okay? So after that, past that point, it becomes very easy. So all you do, you create arrays for every element in A, array for every element is in B. You merge all of the arrays together, right? And then you look for number that appears length of array number of times. So let's say we have 3 arrays, okay, 3 arrays, right? If 12 appears, if we just basically make those arrays, right, and we smash them all together, then we're gonna sort them from small to large. If any number appears 3 times, that means it's in every array. Does that make sense? So if it appears 2 times, it could be here, here, but not here, which means that's not part of, it doesn't satisfy the requirement. But if it appears 3 times, it has to be in every single array. So all we have to do past that point is scan every single number and see, does it appear 3 times? If so, that number is the part of the solution. And then we just find every single number that appears 3 times, and then that's it. Done, right? Again, I'm saying 3, it could be 4, it could be 5, it depends on how many arrays are required to be created. Okay, again, I will leave this in the description below, and also you have link to all of my solutions on my channel, you'll be able to see this document, right? So you can see the solution. All right, so that's kind of, I hope I didn't confuse you too much, but that's kind of the essence of the solution. All right. Okay, so we're gonna be working off. We're probably gonna be working off this thing, honestly. Oh yeah, my apologies. I forgot to show you. That's pretty much it. That's pretty much it, right? That's the explanation here. Okay. So we take the first number. You see, multiply without starting from 0, of course. We start multiply by 1, multiply by 2, multiply by 3, multiply by 4, all the way up to 100. We take the second number, multiply by 1, multiply by 2, multiply by 3, all the way to 100. If there are more numbers in here, we just keep multiplying. And these arrays will go into a holder. I call it like a holder, right? So we just smash them into it, right? Then we do the same thing only for B, which is going to be slightly different, which is going to be factors. So again, we take the first number, divide by 1, divide by 2, divide by 3, divide by 4, right? And then this will give us the factors of the 24, right? And those factors have to divide evenly, right? So like 24 divided by 3, or well, 24 divided by 5 is not going to be here because there is a remainder. So we take 24, divide by 2. Is the remainder? No, we put it into the array. Is the remainder? No, we put it into the array. So we're going to create another array, right, out of numbers from here. So then what we're going to do, we're going to smash all of those arrays together, right, sort them in order of, in ascending order. And then because there are 4 arrays, we're going to look and see how many of these numbers appear 4 times, right? If the number appears 4 times, that means that's the solution. Because look in here, you see 6 appears 4 times because it's in every single array. 12 appears 4 times because it's in every single array, right? So like 2 appears only 3 times because it's not in this array, right? 4 appears 3 times because it's not in this array as well. Does that make sense? 18 appears twice because it's not in here. Well, if you probably keep multiplying, it's going to be here, here, but not in here. So we're going to be only looking for numbers that appear length plus length number of times, if that makes sense. All right. And I think that's about it. Okay, so let's start by creating arrays out of this thing. Actually, I'm going to use, let me just create one. Let A4 equals 2, 6. And then let B4. You can ignore this stuff because I'm just doing it for, so you guys can actually physically see the solution, right? So this is A4, and this is just my test cases in here. You can kind of ignore this stuff, honestly. Because you see we're inputting this and we're inputting this, which is exactly the same as this solution in here. And the outcome should be, the answer should be in here, it should be 2. Okay. All right, let's get started. Okay, so the first thing we need to do is we need to create a, let me just get rid of this stuff so you don't get confused, right? I normally like to clean it up because, I mean, the cleaner your interface is, the easier it is for you to look at it, you know? Okay, so that's what we're looking for. All right, so the first thing we need to do is we need to create a final holder, like let final holder equals like this. Am I recording? Just to make sure. Okay, cool. All right, so now what we need to do, we need to go A for each So now we're going to be accessing this array in here. For each element, console log element, so we'll be able to see it. So it's 2 and 6, all right? So now we're going to create a temporary holder. Let temp, okay. And then we're going to do a for loop. Variable I, let's do let I equals 0, I smaller or equal to 100. And then I plus plus. Now the reason why we're going for 100 is because if you look at the question, there is the constraint for 100, right? So we basically need 100 of those. Now, of course, we're going to filter them out because you cannot divide 48 into 24, right? So, but we'll get to that. At the moment, just do 100, all right? Including 100, right? Okay. So what are we doing? We are basically going to multiply so we need the best way to do that would be to do this basically. If I factorial element equals 0, right? We want to push I, push I. We want the temp, my apologies, temp dot push I, okay? So what that does is, if it evenly divides into the element from the array, we want it to be in here, if that makes sense, right? And then once the first operation completes, so once we run through the 2, we want to push this array into our final holder, all right? And then move on to 6. So once this for loop finishes, we want to take our final holder and then push temp into it. All right, so think about it. How does that work, right? So it first looks at 2. It creates a empty temporary array. It checks to see if number I divided by 2 is equal to 2. If yes, it pushes it into the empty array, right? Once this loop completes, it takes the temporary array and pushes it into final holder. And this is the end of the first element, which was 2. It goes then to 6, right? And it repeats the process. And then it pushes the second array. If there was a third number, it would look at the third number, repeat the process, push the third array in here, right? So this can continue for infinite number of times. All right. So now if we console log final holder, we should have 2 arrays in it. Final holder, right? Yes. Honestly, we probably need to get rid of 0 because it's annoying. Yeah. So you see, it's starting to look like this. 2, 4, 6, 6, 12, 18. If we look in here, 2, 4, 6, right? 6, 12, 18, up to 100, right? Okay. Now, the next thing the best thing, now you do not have to do this, but I did it anyway because it makes the thing look cleaner, right? So, is to filter out numbers that are bigger than this number here, because we will not be able to, 100%, I'll tell you, they will not be in these arrays, so they're kind of total waste of time, right? Actually, we can do it in here, to be honest with you. So if I is smaller or equal to um, b dot length minus 1, and only then we push it, right? Now I don't like this. I know it yeah, you see, so now we're gonna have it's much neater, right? Now I honestly don't like solutions like this. I like to follow what's called a single purpose principle. So every function should just do one simple thing. Otherwise, it can get very, very confusing, right? So let final filtered equals um, final holder. Hmm. Honestly, it's actually probably easier to do it in here. Hmm. Anyway, doesn't matter. Let's do it in here. Okay, so we're gonna console log elements. So now every element is gonna be a separate array. Yeah, so we're gonna have to do it again probably, right? Yeah, this is a bit messy because we have to again create a new temporary array, push into array numbers that are below this number here. Let's do it anyway. It doesn't matter. Okay, so let's do let temp equals like this. Um, element for each. So now we're looking into, or I hope I'm not confusing you, element, let's call this element 2. So now every element 2 is going to be whatever is in this array and then whatever is in this array, right? So now we want to um, we don't even need this thing in here, honestly. And we need to create a new let final holder 2 version 2 equals like this, right? So now we're putting in the condition that we were putting in here. Do you remember? So if element 2 is smaller or equal to b dot length minus 1, so we're looking for anything that is smaller or equal to 36, right? Then we're gonna push temp dot push element 2, and then once this operation completes, we want to put final holder version 2 dot push temp. Okay, now we're gonna have this thing done. So now this will, yeah, yeah. So single purpose principle in here. You're probably, honestly, you're probably better off doing this in here, to be honest with you. Whichever way you want to do it, right? Anyway, it doesn't matter. We already done it, right? We already done it, so. Let me just have a look at the solution to make sure, okay. Yeah, that's exactly the way I did it in here as well. Hmm. Anyway, doesn't matter. Doesn't matter. Okay, so now let's create arrays for the B for the B array. So the B condition. So now we have this thing here. So we've done this array, we've done multiples. Now we're gonna do factors, right? So we're gonna be doing this now, right? Okay, it's very similar. It's very similar. And we're gonna be pushing them into here straight away. All right. So I hope I'm not confusing you. Okay. So the first thing we need to do, we need to look into the B array, right? So there's 24, 36. We're gonna do for each element. Right, so console log element. All right. So now we need to. What do we need to do? We need to create let temp equals like this. For loop let I equals to 0. Actually, we probably don't need 0. Let's just do. And we need I smaller or equal to the element 24, right? Because we're going to be dividing by whatever up to 24. Because if we're looking here, we're going to be dividing up to the number, you see. And then I++, right? So now it's actually exactly the same. So if element, right? If element divided by I is equal to 0, we want it to be in the temp array. So temp dot push I, right? So once it finishes, we want it to be inside of the this guy here. So then dot push temp. So in theory, we should have now 4 arrays, right, with numbers. So final holder. Oh, let me just console log this bad boy. So final holder version 2, right? In theory, we should have 4 arrays now, right? So let's have a look. Yeah, so you see we have 4 arrays. So now what? What do we have now, right? We have every single array that we require, right? Now we need to pick out the numbers that appear in every single array, i.e. numbers that appear 4 times. Okay. So now what do? We flatten the array. That's the best way to do it, probably. Red final one equals final holder. Well, let's do final holder version 3. So we're gonna take final holder version 2, flatten it, sort it. We're gonna have A, B, A minus B, so this should sort it alphabetically. All right. All right, so now we have this. So now we just smashed all of the arrays together, basically. Now we have one gigantic array, okay. And now we need to look for numbers that appear 4 times, right? Is it 4 times? Yeah. So we need numbers that appear length of this plus length of this, which is 4 times. So we call it, let's call it condition test. Let condition test equals a dot length plus b dot length. So anything that appears this number of times, 100% exists in every array. Okay, so now let final holder version 4 equals like this. So final holder version 3, we're going to for each it, for each element. So we're going to console log element. So every element is going to be number from the array, right? We need to create a counter. Let count equals to 0. So now we need to create another for loop, for each loop, right? Final holder version 3, for each element 2. All right. So now you have to imagine what's going to happen first. It's going to take first number from. Let me just remove console log so you'll be able to see it. Otherwise, you might get confused. All right. Okay, dogs. Right. So how do we do it? Okay. All right. So we have double for each loops nested inside of each other. So what's going to happen? It's going to take at number 1 and then go through the same array one by one. It's going to look at, okay, is 1 equal to 1? Yes. If so, count plus 1. Is 1 equal to 2? No. Is 1 equal to 2? No. And then it's going to go through every single one. Now, when 1 is equal to itself 4 times, that means this element is the solution, is one of the solutions. This is a bit confusing, I know, but like, I mean, it's algorithms. I don't know how to make them easier. Do you know what I mean? It's just, unfortunately, that's the way it is. So if element equals element 2, right, we want count plus plus. And then if count is equal to condition test, which is whatever the length, right, we want to push that element into our final holder. All right. Okay, so then we are going to have a basically an array of numbers that appear um, 4 times or whatever length plus length times, right? So this is, and then we like finally we'll just probably gonna have to remove duplicates, right? Yeah, you see, so there's only 2. So finally, remove duplicates. Let's final holder version 5 equals, oh, whoopsie. This one we're gonna take final holder 4. So this one here, right? So that's the one, right? And we're gonna create new set out of it. We just want to get rid of duplicates, right? So we're gonna do new set like this. And then we're gonna create array from new set. And that will give you the solution, right? Yeah, so you see now 6, 12 are the only 2 numbers that appear in every single array. And now the answer, let all done equals final holder length. So it's going to be 2. And that's it, you're done. and then we return all done, right? So that's pretty much the solution, right? Yeah, so now we can take the solution, we can yoink it into and see if it's going to work. In theory, that should work, right? Yeah, yeah, pass all the cases, yeah. And that's about it. Yeah, that's how you do it. Again, I think like the best explanation is just this, right? So when you think about it, all you're doing is you're creating arrays, right, based on numbers in each of the AB arrays, and then you're just finding an element that appears in every single array. And the way to do that is to merge all of the arrays together and find which number appears um, this length plus this length number of times. Because if the element, I don't know, if there is like, in here there is four arrays, right? So if any number appears 4 times, it has to be in every single array because you merge all the array together. Okay, and that's it. If you have any questions, feel free to reach out. Take care. Bye bye.